Hello everyone. Before starting the lesson, try the warm-up. Evaluate by following BEDMAS. This is the order of operations. So pause the video and just evaluate each expression. Here are the answers and how I worked them out. Now, I want you to notice a few things. If we look at A and B, look, we're getting the same answer. And the question involved the same numbers. 2 times 3, 2 times 7, 2 times 3, 2 times 7. Now compare C and D. We get the same answer. The question involves the same numbers. Negative 2 times 3, negative 2 times negative 7, negative 2 times 3, negative 2 times negative 7. You might remember doing this in previous grades, but this is why it works. You get the same answer when you do this, brackets first and then multiply, or multiply each number in the brackets by the number in front first and then add them together. You get the same result. This one's a little less clear to see. We get the same answer, but you might remember doing this in previous grades. 3 times 3, 3 times 7, 7 times 3, 7 times 7, and we work that out. That's what we're doing here. 3 times 3, that's 3 squared. 3 times 7, and then 7 times 3, we're doing that twice. Then 7 times 7, that's 7 squared. When you do this, when you expand and simplify, you get the same answer. And all this math is what we're going to do to change to standard form. So I want you to remember that there's 3 different ways of writing the equation for a quadratic function. There's standard form, factored form, and vertex form. Today, we're going to look at how to change vertex form and factored form into standard form. Because if you have all the different forms, you get a lot more information about your function. So that's why we're looking at how to change from one form to the other. So our goal for this lesson is to expand and simplify to change a quadratic equation to standard form. All right, so let's take a closer look. 2 times 5 plus 3 is 16. 2 times 5 plus 2 times 3 is also 16. So if we simplify that or put those two ideas together, we get this. When you have 2 times 5 plus 3 in brackets, it's the same as 2 times 5 plus 2 times 3. Normally, I'm going to draw it like this. The number in front of the brackets multiplied by each term in the brackets. 2 times 5 plus 2 times 3. This is called the distributive property. Each term in the brackets is multiplied by the number in front of the brackets. So when I see something like this, 2, and then in brackets x plus 3, that means x plus 3 is multiplied by 2. That means x is multiplied by 2, and 3 is multiplied by 2. I'm indicating that with the arrows. So 2 times x is 2x, 2 times 3 is 6, so this is equal to 2x plus 6. So try this example on your own. Use the distributive property to expand. Here's a bunch of questions. Pause the video and just try this on your own. So here's the answers. 3 times x, 3 times 5. We get 3x plus 15. 3 times x is 3x. 3 times minus 5 is minus 15. Just watch your plus and minus signs. Here we have a negative times x, negative 3x. Negative 3 times positive 5 is negative 15. Watch your signs. Negative 3 times negative 5 is positive 15. Watch out for that one. And if you have x times x, that can be simplified as x squared. Just watch out for that. Other than that, just pay attention to the plus or minus signs, and you should be okay. But if you had any issues with any of these and you're not sure what the error was, you should pause the video and ask for help before you move on. Now, take a look at this. 2 plus 3 times 5 plus 3. If we follow BEDMAS, 2 plus 3 is 5, 5 plus 3 is 8, 5 times 8 is 40. Okay, we get 40. Now look at this. 2 times 5 plus 3 plus 3 times 5 plus 3 gets me the same answer. So Like before with the distributive property, if you have a number in front of the brackets, each term in the brackets is multiplied by that number. It just so happens that in this case, we have two numbers in front of the brackets that we're multiplying each of these by. So we end up doing 2 times 5 and 2 times 3. That's what this part gave us. And then we also do 3 times 5 and 3 times 3. That's what this part gave us. We add those together, we get the total. Here it is. You can see the familiar drawing that you might have seen in your previous math classes. This is multiplied by each of these, and this is multiplied by each of these. When you do that, you end up with this. And this is an extension of the distributive property. When we're multiplying binomials, bi meaning two, nomials, the number of terms in an expression, we're multiplying expressions that have two terms. So here's a binomial multiplied by another binomial. Each term is multiplied by each term in the other binomial. So here are several expressions that I'd like you to expand and simplify using that distributive property. So pause the video and try this. If you just need help with the first one, here it is. X times x is x squared. X times 5 is 5x. Now, 3 times x is 3x, and 3 times 5 is 15. So we have all these terms, and these two terms, 5x plus 3x, are like terms. I can add those together. 5x plus 3x is 8x. Now I don't have any more like terms. This is as simplified as I can make my expression, and so that's it. So if you need more time, try the next on your own. Here you go. Take a look through. Watch your plus and minus signs. For example, if I have a positive 3 times a negative 5, that's a negative 15. If I have a positive x multiplied by a negative 5, that's minus 5x. If I'm multiplying two negatives together, it's a positive. Watch out for little details like that. Down here, if I have a negative sign in front of my first brackets, multiply out the brackets like you normally would, and then apply that negative sign to each term, which makes all your signs opposite. If you need more time to look through this, pause the video. And if you have any issues and you're not sure why you're getting something different than I did, you should pause the video and ask for help before you move on to the next part. Now look at this. 2 plus 3 squared is the same as 2 plus 3 times 2 plus 3. So all I want to show you is that if you're squaring a binomial, you're just multiplying that binomial by itself. And we just looked at how to multiply binomials by other binomials in the previous example. So it's really the same thing. Now, I want to point this out. Bob says that x minus 5 squared is just x squared minus 5 squared. Is he right or wrong? Why don't you pause the video and think through this before you check in? Well, he's wrong. X minus 5 squared is x minus 5 times x minus 5. That's what squaring means. It means you're multiplying it by itself. And when we multiply that out, we get x squared minus 10x plus 25, not x squared minus 5 squared. So this is actually a very common misconception, a very common mistake that people make, and I don't want you to make that mistake. So just remember, when you have brackets squared, it means the brackets times itself. So now it's your turn. Pause the video and expand and simplify these expressions. And here you go. If you got something different and you're not sure what the issue is, you should pause the video and ask for help before you move on. Now just watch how I do this. I'm asked to expand and simplify. Here I have brackets squared with a number in front of the brackets. I'm first going to remember bed mass. When I start evaluating, I need to do brackets, then exponents, then division and multiplication, and then addition and subtraction. So, brackets, here's some brackets. Can I do anything in the brackets? No, because these are not like terms. So now I move on. Exponents. Here's an exponent. What does it mean? It means I'm multiplying these brackets by itself. X minus 3 squared is x minus 3 times x minus 3. So now I have to do that, and I carry that out just like I did in the previous examples. X times minus 3 times x, and minus 3 times minus 3. That gets me this. And I'm going to simplify that. Now I have this multiplication. I have a 5 in front of the brackets. Remember what that means. The 5 gets multiplied by every term inside the brackets. So when I do that, 5 times x squared is 5x squared. 5 times minus 6x is minus 30x. 5 times 9 is 45. I don't have any like terms, so I can't simplify this any further. That's it. So to expand and simplify this, I did the exponents first, multiplied, and I got my final answer. So now it's your turn. Pause the video so you can try to expand and simplify each of these expressions. Here it is. I've modeled the first two very explicitly. I left out some details for the last two. If you're not getting the same thing as me, you should pause the video and ask for help before you move on. All right, watch and learn, everybody. We're going to step this up another notch. Expand and simplify an expression like this. I like to break this up. I'm multiplying these binomials together. I'm multiplying these binomials together. Work those out separately, and then subtract whatever you get from this from whatever you get from this. This is what I mean. Multiply these together. You end up with this. Simplify it. Over here, you multiply these together, you get this. Simplify it. Now we're subtracting that whole thing, so that means we're subtracting 8x squared, which means we're got minus 8x squared. We're subtracting 2x, so that's minus 2x, and we're subtracting minus 3, which means we're adding 3. Put my like terms together. 3x squared and minus 8x squared are like terms. 2x minus 2x, those are like terms. And minus 8 plus 3, those are both constants, so they're like terms. Simplify. 3x squared minus 8x squared is minus 5x squared. Positive 2x minus 2x, that equals 0, so I don't have to write anything. Negative 8 plus 3 is negative 5. I don't have any more like terms, so this is simplified. That's it. Now you try it. Expand and simplify this expression. Pause the video and try this one. Here's what I got. If you got something different and you're not sure why, let me know before you move on. So the whole point of this lesson was to show you how you can expand and simplify so that we can do what this question's saying. Changing an equation from factored form to standard form. So change the equation to standard form. You do that by expanding and simplifying. So pause the video and try this one, and then see if you can relate that back to the graph. Some questions about that. So pause the video and try this. When we expand and simplify, we end up with this, negative 2x squared plus 6x plus 80. This is the standard form. So because I started with factored form, that tells me what the x-intercepts are. Remember the signs switch, so plus 5 in the equation means you have an x-intercept of negative 5, and this one would be an x-intercept of positive 8. The y-intercept, you get that from the standard form. The constant number is 80, so the y-intercept is 80. And these are the coordinates of your points. Now here's another example where I'm asking you to change an equation into the standard form. This time we're starting with the vertex form. And then I have follow-up question about the graph. So use what you have learned so far and try this one on your own. So pause the video and see how you do. This one is a little bit different for expanding and simplifying simply because we are subtracting a number at the end. But start with your exponent. That means x plus 5 multiplied by itself. We get this. The negative 2 in front means everything in the brackets is multiplied by negative 2. And then we can subtract 4. We'll just put our like terms together. Negative 10x minus 10x is minus 20x, and minus 50 minus 4 is minus 54. So this is the standard form. We started with vertex form. So when I look at the direction of opening, look at your a value. It's negative. Doesn't matter where you look. A is negative, which means we open down. The vertex comes from the vertex form. So the coordinates are negative 5, negative 4. And the y-intercept, we get that from the standard form. So we know that the y-intercept is 0, negative 54 on the graph. Now, if you're up for the challenge, here I have a function in factored form, and I want you to determine what the x-intercepts, the y-intercept, the axis of symmetry, and the vertex are without using a graphing calculator. See if you can use what you have learned about quadratic functions so far to figure out all these pieces of information. So if you're up for the challenge, pause the video and try this question. Well, here's what I got. And the way I got it was the x-intercepts come from factored form, so I know it's 2 and negative 4. Plot those on the graph. I know my graph opens down, so that gives me the shape of the graph. My y-intercept, I know it's going to happen on the y-axis when x is 0. So if I find the value of the function when x is 0, plug in x being 0, do the calculation, 6.4. I don't have to turn this into standard form, but you could have found it that way too. Either way, you get 6.4 as the y-intercept. The axis of symmetry, well, remember, the graph is symmetrical. So if you know your x-intercepts are negative 4 and positive 2, find the number that's halfway between those on the number line. It ends up being negative 1. Here's how I did it mathematically. If you want to know the number halfway between two values, take the average of the two values. Either way you do it, x equals negative 1 is the axis of symmetry. The vertex, well, I know the x-coordinate of the vertex is negative 1. I got that from the axis of symmetry. So if I find the value of the function when x is negative 1, replace x with negative 1, calculate, it's 7.2. So now I know the coordinates of my vertex are negative 1 and 7.2. So that's how I can build a sketch of my graph and find all these points using only the factored form. So the overarching idea in this lesson was that you can expand and simplify to turn vertex form or factored form into standard form. And that's what you're going to practice. Now, you might be asked also to relate the equations to the graph, but that was covered in the previous lesson, so you can focus on that as well if you need to. So as you're practicing, reach out for help if you need it, and I'll do my best to help you.